Cool. Right. So what I want to do, let me just keep an eye. Cool. That's the other time. Let me walk you. I want to walk you guys through the sort of my experience in the last sort of year in basically doing a sort of a startup around GenAI and sort of shifting to the GenAI world that I've been really probably being a roller coaster for the last 2 years. And sometimes it's quite embarrassing because I'm sometimes on these forums and these places where there's like individuals that have like 10 years, 15 years of AI experience. I could say I have about 25 years of cybersecurity experience. I can say I probably have 38 years of programming, right? So a bit of that. But I really didn't like AI until ChatGPT, because for me, a bit like blockchain and a couple of others, right? Like for me, most of the AI was machine learning, and I always felt that I could do what the AI, especially cybersecurity stuff, could do with better data and better workflows, right? It felt to me a massive brute force. Then ChatGPT happened, and things changed, right? So let me walk you through it. So I was kind of, for a while I've done security law stuff. I've been at OWASP, but with AppSec. I kind of, and I highly recommend this. I waited quite late in my career to become a CISO, and then a CTO, and then a CISO again, because I wanted to be the most technical person in the room. I never liked this idea of execs that say, I have no idea about what's happening in my industry, I just delegate stuff, right? So I basically wanted to make sure that by the time I was in charge, I actually knew exactly what was happening, and I felt I was still one of the most technical persons in the room, and he made a massive difference. He actually showed me that, I kind of felt that I was still hacking on my way into this, right? I remember buying the first copy of Hacking Exposed, for the ones old enough, right? My nice little red book, right? But I feel like even here I was still hacking away. I was just hacking the organization, instead of hacking things. Just figure out how to get stuff done. So these days, I have a startup. I'm doing this thing, Cyber Boardroom, which I will talk to you guys about. I'm still kind of chief scientist here, which is a really cool UK company. It's another bigger startup. We make files safe, work for the government, so very interesting. I do a lot of stuff open source, and I kind of also run this sort of Open Security Summit. Some of you guys might be part of it, etc. So when I mean AI in this presentation, I mean GenAI, right? There's all this other stuff, and to be honest, I think there's still a lot of use for that. I actually think that GenAI can help us understand what the hell's going on in that world, but I mainly focus on the sort of generative AI, the sort of the bit that uses the models, which, by the way, we still don't know how it works, right? So just take that into account, right? We still don't know exactly how that thing works, right? But for me, it is the big change, right? So if you want to take one idea, right, from this presentation, one, and this is the thing I have to say, I feel this is the most important thing that you can do and anything can do, because this has the maximum, I would say, leverage and amplifying effect, right? Is key to scale and impacts everything, right? Is invest in your NFR. Anybody know what NFR is? I had it really small there and white.
Non-functional economy.
Correct. This thing, right, is probably the single biggest flaw that I've seen everywhere, which is, it's actually ridiculous. We invest in everything except how sometimes we work, right? And those non-functional requirements, which usually don't get funded, don't get time, don't get investment, etc., are the thing that gives you leverage. These days, I'll argue that your test code, your test infrastructure, is more important than your main code. The reason why is because your test infrastructure makes your main code better, right? You can't have really good code if you can't test it effectively. It is that simple, right? So, everything we're going to do here is available online. This is one of the things I'm most proud of, right? Actually, this, again, little typos I was fixing away. Not last 2 months, probably I should say last 7 months. This is from my previous slide. But I'm super proud of this, right? Because this is a place where I can make a change here that tags everything, published to PyPy, puts on Docker Hub, puts on Google Clouds, triggers another project, puts on AWS Lambda, runs on AWS ECS, and published to EC2. And I could add all the other ones, right? So one of the big lessons I learned was that whatever you develop has to run everywhere. And the only reason you won't run everywhere is because you have tech debt. It's because you already have a spaghetti code that runs somewhere, and you probably have 2, 3, 4 copies running in production. And by the way, failover, 1 and green and blue and big deployments, that doesn't count. My point is that you should be able to take whatever you're building and ship it anywhere from scratch on a clean environment. If you can't do that, you have ridiculous amount of tech debt that you don't understand. And actually, there's a lot of business models that you cannot get into because you can't do that. And see non-functional requirements, right? That's the key. And it was interesting because I spent the first couple of months when I got into the startup building all this, because I thought this would have been easier, right? But it wasn't, right? And by the way, from a security mind point of view, I argue that we need a lot of new people to come into cybersecurity because I've always been a fan of professional recruitment, right? Hiring people from other industries. I hire people from NHS, get somebody who work in an emergency ward, on the NHS, they can do instance response, right? They're very good and they're calm under pressure. I hire shop assistants. We had once a dude that was running, I think it was like, an SS scan inside one of the warehouses. We detected him and we hired him, right? So I'm a big fan of hiring people from all the industries into cybersecurity because they bring a lot of mindset, a lot of great assets to our industry. But I also argue that people from cybersecurity should go to other industries because we have a different definition of reality. What I found when I was doing CTO, even in doing development, the biggest obstacle sometimes to some of the ideas is the other technology crowd who basically says, oh, but that's not how it's supposed to work, right? Or, that's not how Kubernetes work, or that's not how you're supposed to use Lambdas, or that's not how you're supposed to do those things. I think in cybersecurity, we have a great mindset that I think we should bring to other industries. And I think a lot of the stuff I do is kind of based on that. I just keep asking why, I keep refactoring until I go to the heart of what it is. Right? So everything I do is on PyPy, is on Docker, AWS, right? And then, again, just for example, everything creates a new AMI, which is great, right? So then when I pick up, that picks up by this, so this is actually a really cool solution, by the way, right? In AWS, for example, but every cloud has this. If you develop an AMI, then you literally, if you can have all your app running in one AMI, right, i.e. a Docker container or an image, right? You can literally build a ridiculous scalable solution that will scale, almost at the speed of AWS, right? The only question is state, which again you should be managing, which is another reason why I'm a big fan of no databases. I use the file system as a database. And so this is the other thing, right? And I've been posting a lot of stuff on LinkedIn now because I've been trying to document better this workflow, right? So these days, before I write one line of code, right? One line of code, right? Before I even figure out what I want to do in that module, I deploy this, right? I deploy something that has a Git repo, has a fast API, so API first, right? Has a CI pipeline, which is there, has unit integration QA tests, have 100% code coverage. And by the way, if you don't have 100% code coverage when you have little amount of code, how the hell are you going to get that when you have a lot of code, right? And again, 100% coverage, like I said in a slide, Lex is not the destination, it's almost a minimum requirement, right? What you want to think is if you don't have 100% coverage, what parts of the code base are you not testing? What part of the code base is making random changes? Because nobody picked it up, right? So I got auto tagging, which I'll talk in a second, which is absolutely critical. I create a Docker container, I push Docker container to ECS, but by now I could have done anywhere, right? Lambda function, serverless straight away, AWS function URL back. So that means that before I write one line of code, I have a running website, running serverless, that has zero cost to run because serverless goes up and down, and I can make a code change. And the other thing that's very important here, I already have very important tests that allow me to test, for example, a fast API directly, a fast API from the client, and even a fast API directly by HTTP, right? So you can see I run my tests, I increment the tags, again, I'm coming back to that, tagging is very important. I publish to PyPy, again, immediately, like each one of these was like a week of development. It's quite funny, like I tracked down my year by like figuring out it should be easy to deploy to PyPy, right? It's not, right? Or there's curveballs, there's things you need to figure out, right? Consuming, poetry versus Py stuff, whatever the other one's called, right? So all these things, right? Then publish to ECR, again, there's curveballs in there, but this by now, this could be, Azure, this could be Google Cloud, this could be IBM, this could be whatever you want, right? Because now by now it's a container, right? And then deploy Lambda function, run QA tests on top of the Lambda function. Right, so these QA tests don't run here, they run on there. They expect the site to be deployed. Right? So again, when I'm running locally, my QA tests run locally because I have the local version. Right? Again, see, this is what I mean by non-functional requirements. Right? If you want to see a healthy team, figure out who's paying for this. Because in most teams, nobody's paying for this. Or it's the DevOps teams, right? Which we throw over the fence and they figure it out, right? Which doesn't work, right? Well, it works to a lot of degrees, but it's not very efficient. Right? So I work on this thing called the Cyber Boardroom, and I kind of doing this because I think it's a really cool idea, but also because I needed something that was tangible. Right? I like to work on something that is really real. So what am I doing is because we need better security decisions, we need to translate the collaboration platform, basically the Cyber Boardroom. Fundamentally, the problem is that we have a whole pile of board members. Actually, this slide is wrong. Is this one here, right? Is Y. Sorry, okay, order is wrong. Right? So the Y, and again, the whole thing starts with Y. Right? If you haven't, by the way, haven't seen that from Simon? See that? Great presentation. Start with why is that the board members need to understand what the hell we're talking about, right? Because for most board members, they have no idea what cybersecurity, and one of the things that really, really pisses me off is when cybersecurity people denigrate board members. And they say they're not very good, they're not very clever, they're bored. My experience is they're super clever, super sharp, right? If they're not, they don't last in the boards. What they don't understand is technology, because they're not supposed to, right? Your job is to translate to their environment. Right? The problem we had was how to scale it, right? So my challenge was, eventually I realized, it's all about stakeholder management, the RASI matrix, and all that stuff, right? You make sure you keep people aware, don't have surprises, brief people before happening, all that stuff, which is super important. The problem is, how do you scale that, right? I could barely got my team to document what the hell's going on, right? If I asked them to create 25 presentations for different execs, right, they all quit, right? And so basically we have a problem there for board members to do that, but also the CISOs have a massive problem to translate stuff, right? Like it's very hard. It's very hard to translate this. You need empathy. Like I'm okay, right? But I'm not, nobody's really that good because you really need to focus, right, on their stakeholders, right, and what they care and how it works, right? So that's the problem I'm trying to solve, right? I'm trying to solve in cybersecurity because it's a big problem. It kind of exists everywhere, but let's start over there, right? And basically what you need is this personalized, right, in business, up to date, in their language, actionable environment, which is these insights about this. But also, the CISO needs a scalable platform to communicate, right? So fundamentally it's this, right? The Cyber Boardroom provides a whole bunch of stuff. I have a whole bunch of bots, right? And that's how I started. Really cool, right? And you'll see in a second, right? It's, the challenge is making this work, right? But that's kind of what I'm doing, right? So, I want to walk you through a whole number of problems, how I solve them, and then we're going to walk you through some case studies, right? And you're going to spot a pattern in just a second, right? So, the first problem is, and this is like literally 10 months of my life, all open source, right? So the first problem is, I needed a good CI pipeline, good version control that I could deploy everywhere. So, that repo has all the actions you need to pull that off. Really cool. Now, I just, we use those actions everywhere, and you go from there. Auto tagging, right? I'm going to keep you back to that one. Is one of the most important things you can do, right? Because actually, in Git doesn't track back where you were when you merged stuff, right? So it's really hard to know what the hell's going on, right? The other one is I need a graph DB, right? I've been a graph fan forever. Hey, Sam. By the way, look, this is open source project, by the way. This is an OS project. Actually, Sam was the one responsible for it. So I remember publishing the first versions of the OS bot. It's like, dude, why don't you put your OS project? It's like, yeah, okay. So there it is. It's called OS Security Project, right? Security bot, sorry. And so this is my latest stuff. I'm super proud of this because finally I was able to pull off in the last month something I tried many times before and I could never do. And this is the power of the LLMs and especially ChatGPT, but mainly Claude. I have a development environment now that is ridiculously productive. Right? And I created this graph database, which for me is really freaking cool because it's serverless and it's file-based. And it actually scales quite nicely. And that was a piece of the puzzle that I was missing. So you can see that what I do is every time I have a problem, I'm trying to, basically what I do is I have a problem, I go, this should be easy. Right? So what I then do, I go, well, I'm going to build something for it if there isn't something already there. Right? So then I go, well, I need a nice way to do APIs. Fast API is great, it's not very easy to use, there's lots of plumbing we need to do. I build an open source project for it. And by the way, my expectation for this project is I'm happy for them to disappear, right? I just want the most efficient way to work to be the one I can work. And that's the power of openness, right? In a way, it allows you to almost treat technology as disposable, which is very important. Like a lot of companies fall in love with their tech, they think it's so precious, right? And then what happens, guess what? Things occur, right? Or events, people evolve and technology evolve and you get left behind, right? So I needed, basically this is really, how many people here know local stack, by the way? All right, if you guys, either you should know about it, right? And if you don't, your dev team should know it because it's a ridiculous in a way, piece of tech that solved me tons and tons of problems, right? So local stack is literally a local copy of AWS, right? So what they've done was they're like, hey, AWS has published all the interfaces by Boto 3, let's freaking reverse engineer it and create a version that runs off Docker, right? And they've done that also for other places, but the power of this is that I used to do all these jumps and hoops and have these different things from local and not local, and I then had a problem I couldn't run everywhere. Now, I put my app, a copy of local stack, that's the only two containers I need to run my entire app, right? And one is on AWS, it goes native, but it's powerful because I got lambdas everywhere. That would be the most important thing for me, S3 everywhere. I have a file system that scales, and basically my code now has no way of knowing if it's running locally, on AWS, on local stack, etc. It's really cool, right? This was a massive game changer for me, right? Again, another tangent. Now, this thing here, which actually is almost my favorite project, is a collection of my last 10 years of development, right? This thing has almost everything you want to do in Python, probably it's there. There's no dependencies, right? And because I got annoyed of having to import dependencies because of one little thing, right? So I start adding them. And the one I've done recently, again through Claude, is this really insanely powerful type-safe class, which actually does runtime checking, right? Which is actually really cool, because I don't think any of the other type-safe does. But it has tons of power tools, parse XML, method caching, there's a SQLite database, call traces if you want, and again, async. Again, this might mean nothing to you, but if you ever done sync and async programming in Python, you know it's a freaking pain in the ass, right? So again, like all of these saves me time, right? That's the difference. And all of this, there's one big theme here, is make it simple. And the other big theme here, and this is something I've learned, doing this, and also in music, because I play music, right? And there's something that grooves when you're in a kind of a real good band, is that what's interesting is that I realized that in most places, the more code you have, the slower you go, right? Which is a really weird thing, right? Because technically you have more tools, you have more capabilities, you have more people, right? What I experienced was, if you have this approach of the non-functional requirements, which are all of these, by the way, right? To make it simple, to make it effective, etc., you end up in this really cool place, which is the more you have, the faster you go, right? So this is really cool, right? I got to the point where, in a way, what I'm doing here, and by the way, this is the worldly map, right? Innovation, level, and commoditized. If you don't know what worldly maps is, you really should, right? Lots of stuff online, word lake maps, right? But what I'm doing here is I'm commoditizing these modules. I'm making them easy. I'm basically saying, this should be easy. I'm going to make one little call, and I hide the complexity behind it. And that means I gain speed. I don't have to solve problems. I can work then, like for example, the graph database now knows how to load JSON files directly. Now I can just query it. I don't have to worry about my next project when I use it, right? It's ridiculously powerful. AWS, that's the other super powerful one. Border free, it's lovely, it's still a pain in the ass to operate, right? Like if I literally always, if you look at my methods, I always like instructions. Do this, connect this, open this, do that, do this. Like I can deploy a Lambda function, right, in 3 seconds. Right? That's crazy. I remember once my party trick, I would go to somebody and say, hey, how long will it take you to write a bit of code, then package it on the function, then deploy it to AWS, then see the thing change, right? And it kind of ranged from a couple of minutes to like a week, right? Or when I say a couple of minutes to an hour, I got to the point where I kept reducing, finding exactly everything works. I now get to the point where I can literally make a code change, run a unit test, and that unit test takes the code, zips it, sends it to S3, tells AWS Lambda to go to S3, pick it up, update the Lambda function, run it, and it used to actually take 2 seconds. AWS now added some weird delay on it, right? But it's still ridiculously fast. The point is that I kept going it. I kept figuring out how can I make this faster, simpler, right? More effective. And of course, that you don't use it in production, but it's massive power to have this in development, right? So again, I need route automation, so I did Playwright. I used to use, Python before, right? I did LLMs, I make it simpler. I did Markdown, kind of start the team, right? Docker, right? So all of the open source projects, by the way, right? And then now on the CBR, so the thing I realized when I was doing Cyber Boardroom is that personas is one of those things that we really have a bad deal at the moment, because most websites give you one persona, right? And they're designed for you to have one account. And what I realized is that the Cyber Boardroom is all about creating custom personas. It's all about you being communicated in different ways. So I basically added native support for you to have multiple ways to view a data, to have multiple personas, to take a guest persona, right? So that's what that repo does. Super powerful, right, on doing that. The other ones, I needed a way to manage user sessions. Again, this is a cool example of security. Each one depends on different things. They're all isolated. I needed static content. All my static content is there. I needed a way to generate feeds. So I'm now creating this called My Feeds AI, which actually is what I'm now doing for the Cyber Boardroom, which is I'm now taking all the cybersecurity news feeds, and then I'm basically giving you your version of those news feeds. So in fact, if you want to use the Cyber Boardroom in a really effective way, or even this, I'm pretty sure most of you don't get a nice personalized cybersecurity feed of what's happening today, right? So that's what I'm building on, right? And this is going to be super cool. And it's basically, again, applying GenAI, applying the graph database. That's why I have to develop the graph database, because I need a graph database to put my security feed so I can create a semantic knowledge web out of it. So then I'm using graph RAG instead of normal RAG, which kind of sucks, right? And then, convert file. This is another massive big one, so I'm actually using, I think it's Markdown. But again, this is just a web service. Right? Little web service that now runs on AWS. You take a PDF, it gives you Markdown. You take a Word document, it gives you Markdown. And again, super cool. Runs serverless, costs nothing when it runs, when it's not running, right? Scales until tomorrow, right? Great example of that sort of going too fast. And this is the other one. Right? The other one that I went on an interesting tangent here was that it really bugged me how you develop HTML, right? It's like, it's a massive salad, right? It's, you can't freaking test it, you can't have components. It's a massive shit show, right? Like developing HTML, right? And you can see that, like even the big guys, you go, and then I looked at it and going, whoa, these guys develop web components, right? Web components are freaking brilliant. They're isolated, they have their own DOM, right? Super cool, they were hard to do. So again, I spent the time making super easy, now fully tested. So again, I went on a tangent, but now when you see the Cyber Boardroom, every one of these little dudes is a component, isolated, and there's like an event-driven architecture, which is really cool. So no component knows what's going on, they just receive events, right? And that's the kind of, again, thing you can't really develop unless you have A, really cool LLM supporting you, B, a really good way to run all the tests. And everything is managed by PyPy, and everything managed by submodules, right? So again, this is an interesting thing. You might say this is complexity, I view this is simplicity. Right? Because this allows me to have a very clean air gap between the different systems, and allows me to actually, I even mix some of the workflows, because I think they're nice, they give you some things. So for example, I have one workflow that actually consumes the data directly from the repos, I have another one that uses PyPy, so I know that if all of them are working, the system is actually pretty cool, right? So, right, this is a very important point, and I think a lot of people don't get the power of this. Some guys do, here's a good example of, you're doing a great project, the thread model. StratGPT, right? Great example, right? Again, follow him, right? He's doing a good example where the journey is the story, right? And for example, I wouldn't be here if I haven't been, basically documenting my story. So let me be cheeky now and use my own LinkedIn post, right? To tell the story of what's going on, right? So, key lessons I learned, and then build a community, right? On top of this. So the first one is that, and I posted this recently, I says, if anybody's still saying that LLMs are the statistical figuring out the next word, right? They really don't know what they're talking about, right? So just to be clear, I think GenAI is a ridiculous technology. I think it's the biggest thing that we're going to have for a while. I also think it's ridiculously dangerous. I'm going to cover that in a second, right? And I think there's one way to use it that's super safe and very powerful. Another one that is a massive shit show that is really going to, it's already starting to, but it's going to get even worse. And security, if you think we were important before, we're going to be even more important coming next, right? But this is really cool, right? So in this case, I just went to him. This is Claude. I use Claude a lot these days. I really like Claude, mainly because of the projects, and it's, it has a really good sense, right? But you can do this equivalent thing with GPT-4o, right? And 1. So basically, I'm working on this, and let's look at this. I'm working on this stuff, right? And one of the things I really like is I'll show you, I'm now creating all these tech docs, right? And I give it to the LLM. So not only I document a lot what's going on, I actually feed it to the LLM to go, hey, this is the context of what's going on. So in this case, I gave it the information, I gave it the source code, this document was already there, available, right? And on these two files, can you focus there? And can you see what the bug is? And actually, it was absolutely spot on, saying, here's the bug, right? You're going to give you a fix, right? So this the way I want to think about this is that, for me, the best way that I have to understand what the LLMs are doing is that the LLMs build a graph of what you say, right? So your prompt allows the LLM to do a graph. I actually think that the most interesting thing happens before they say the first word. Because what the LLMs do is they build a model, right? A kind of a version of the world, if you think about it, or a representation of what you asked. The difference is they don't work in 2 or 3 dimensions. They work in 1,000 dimensions, right? So that means that the richness of that graph that they have internally is super powerful. In a way, it's easy for them to answer these questions once you have that graph, right? Which is kind of what we do in our heads too, right? We have relationships, we have graphs, etc. So it's ridiculously powerful. And these days, this is my workflow. My workflow is I do some code, I write some docs, I put it on Claude. I literally have full-blown debates with Claude and about the architecture of the things I'm doing, right? Which is ridiculously powerful, right? So I can't stress how important it is to tag everything. Should I say it again, right? And the workflow I have is every push to dev increases the small one here, and every push to main increases that one, and then V1 is just more like a manual. Oh, it's big enough, I'm going to make a major version, right? But what's powerful about this is that every single commit, like for example here, every change gets one of these, right? And you have to do this for everything. I just want to show this code because I do this for content, right? And the reason this is so important is that I can take this bit out if I needed to. I know where I was, I know where I'm not. And if you think when I was showing the sub-modules, the bigger one, which is the one actually that you have here, this is actually the biggest one, right? Because this one depends on all these models. But I know each one, in fact, it's annoying for me that GitHub doesn't give me the tags here, because I wish it did, right? Because each one of these has a tag, right? So, in fact, I've done this before manually, or with the automation, right? But it's so critical that I can manage every single dependency like that, right? So you need to do this for everything. In fact, you need to start doing this for the LLM's workflows, right? We need to start doing this for every step that the LLMs do, because we need to have deterministic. We need to have traceability, right? And Git is the best way to do that. Right? So, this is the other one that, if you're not doing this, you're missing a ridiculous trick, right? So these days, my workflow is, I basically have this long conversation that's with LM, and at the end I say, can you collect everything you learn on this conversation? And you can give me a technical debrief of what we talked about here. So they can go from, how something works. Here's my setup. It can go from a bug. In fact, I even do these days something like, I want to write something, I create the brief what I want to write in first. Now, the difference is, in the past, I couldn't go to somebody and say, hey, can you give me a 20-page document about what you want to do, right? Most teams these days barely do 1 or 2 paragraphs, right, about what's going on in the backlog, right? But imagine having a 20-page document. The power here is that when I look at this, I have 0 emotional attachment to the structure, because I can go to Claude and say, hey, can you change the structure? Can you add this? Can you modify that? Collective, you, right? So here's an example of, I was writing a document, then I started to implement it, at least that's my prompt, right? I go, hey, I don't like the structure of the edge to contain this. This is when I was developing the graph database. What do I do to do this, right? So especially Claude, it's really good at it. He goes, oh yeah, that's much cleaner. What about this? What about that? Here's my thinking. So again, read that document. That's from my newsletter, right? But this is the kind of things that I did, just to give you an example, right? So in fact, this document was actually created because I finished this session, and then I asked Claude, hey, can you give me an article about what we just had, because I think it's a cool example, right? So look at the question I have. So there's 3 types of nodes, and then he clarified, what if instead of doing this, we actually did it like that? On this, what about happens when you do this? So basically, I'm clarifying my thinking. So when people say that, oh, the LLMs reduce your critical thinking, I'm like, bollocks, that's usually wrong. My critical thinking is getting even better. Because I can challenge, I can explore, I can see I have an idea, I can see what it looks like, I can try it out, and I can try different conversations, and this allows me to go really, really deep. Like, imagine having this for thread models, man. Like, I want to do this stuff, right? Because this allows me to have conversations about the architecture, conversations about the design, but also get diagrams in the back of it, get really full 20-page documents, right, that represent what I want to do, which of course are crazy powerful because I feed that to the next prompt. So the next prompt is, hey, we worked on this, let's go. So I've been documenting this, And in fact, it's one of those things I started doing it and I kept doing it. So now I have literally 39 posts, right? And every single one of these has probably, 90% of these has a 20-page document, right? And by the way, create a document is the only bit that's, I need to automate a little bit because it's a markdown. I go to GitHub, I create a PDF, but I like to format a little bit so it doesn't matter. But what's cool about this, you can see the history, right? So you can see, look, the type safe tech documentation, tag safe as a frameworks, the code document of one code to another method, and it became 11% faster. It's like, what the hell? But I haven't changed anything. So then I went on a massive tangent, and then I learned a lot of things, why it happened, then I did refactoring strategy. So what's cool about this is I went from kind of here and here. All of this was figuring out the problems. And then here I went on a tangent because I was like, ooh, my GUIDs are too expensive, right? I need a better way to generate GUIDs, right? Because they're too expensive, right? So you can see a whole debate I had, including security here. Then I went to do the graph, then I got visualization, and this is the article I'm going to talk about, and then this is the graph. So you can actually see, first I solved all the types of problems, then I started implementing the graph, and then by here, I started to add support for Cypher, then I had Mermaid, then I had Dot, Network X, and then, and then here I'm actually doing the query, and then this was pretty cool. So here I built the query, here I did a redesigned brief, and literally 30 minutes later, I had a second brief. Right? Now, again, this is a 20-page document, that's a 15-page document, 25-page document. The coolest thing is that, again, I have no emotion connection to the briefs. I want the best idea to come out. So it's really powerful because you just evolve super quickly, right? Again, if you're not doing this, and if your team is not doing this, you are not really leveraging the LLM. This is the power of the LLM that we have today, right? And that's why I capture these documents, right? So on this particular article, I talked about beyond static documents, right? There's some really cool stuff. And some of these articles, where I write these articles is I have a chat with ChatGPT on audio, right? Where I basically do a brain dump of everything I want to do. And then what I do is I ChatGPT grabs some niche analysis, but mainly I want the transcript. I take that to Claude, and then I have like 4 or 5 rounds with Claude to improve the document, improve this, add this, and then I clarify some of the sections, and after that. Anything apart from code injection, right? So that's the key, right? But if you build your own model, if you customize stuff, then it's a massive shit show, right? And you're going to be struggling with it. Which a lot of people like, right? So this kind of the patterns here are kind of, this is a bit boring now because most of you know about these patterns. The one I kind of want to mention, so you ask a question, get multiple answers, right? This is quite cool. You ask one question, multiple models, you get an analyze to summarize, then you forth, and then you go, hey, here's the answer, right? That's a really cool workflow. And again, the cost of this is going down, so you want, and by the way, if they agree, cool, right? If they don't agree, you go, ooh, something wrong. Right? So that's how you should be thinking about your LLM prompts, right? I really don't like RAG, right? For a lot of reasons. Read this. I like basically, because for me, this is the black box, right? Vectors, right? I prefer graph, right? I prefer a graph RAG, right? Where basically you create a semantic knowledge graph of the thing, right? And now I have a graph database into it, right? So finally, right, a couple of things, right? Fundamentally is input, that output. So what you don't want to do is this, massive black box in the middle, right? It's a magic database, it's a magic worker, right? It's ridiculous, right? Like, it's one of those, right? If you've been in security for a long time, it's like, hey, what can go wrong, right? And then, it's all about this. You take an input, you apply AppSec and prompt engineering, right? Then you have the black box. Then you freaking contain the hell out of it, right? Then you have a proposed solution. Then you have human verification inspection in the beginning. Then you have ownership. This is super critical. You have to have human ownership of what's going on. And then you give the solution, right? You can scale a lot of this stuff with DevSecOps and DevOps, right? But what you don't do, right, is because GenAI is your most vulnerable API. In fact, is your most dangerous insider threat. If you think about this, right? In the past, insider threat was maybe some disgruntled person, etc. Now imagine your AI being compromised by an instruction that you had no idea how it got there, was now popped, and now it's attacking you. So imagine if that freaking thing is now attacking you, which is why you need to contain it over there, right? So basically, not that you put this by CyberSec, and what you really don't want to do is take that black box, connect it to your cloud environments, connect to your corporate environments, and connect to your customers' environments, which is what a lot of people are doing, right? that is, again, it's one of those like, what can go wrong, right? So, we don't want to do that, right? So you want feedback, and if you want to be really cool, what you do once you have this, you use incidents here to, whenever this goes weird, you trigger an incident, you go back, you customize your prompts, you go here. The problem is, if this thing happens and you don't have provenance, and you don't have good observability, you don't have a very good understanding of what your LLMs are actually doing, good luck debugging the thing, right? And especially when you have an LLM that now could be compromised or change your behavior, what are you gonna do? Throw the LLM out, get another one in, right? So that's why you wanna make sure that whatever happened in that black box is as controlled, as small, as effective as possible, right? So again, it's a perfect time to learn how to use this. Don't miss the revolution, don't miss this revolution. I think if you guys are doing a startup or involved in this, you should think about it, because, and I'm almost finished, right? There's a great image. There's a great image that I heard. There was this great podcast. I think it's called Prompt Something. But and there was this lady who said there was a moment where she was reading her book to a kid, and there was this moment of somebody on the prairie or Portuguese who were sailors, right, looking at the sea, and that idea of the unknown, right? That idea of like, wow, this is amazing. What's on the other side, right? And she, the story the lady said is that she was quite sad because she felt we got past it. Like, think about it, like 5 years ago, that generation was depressed. Like, you guys blew up the planet, you blew up the economy, you blew up work. It's like, what the hell, what can we do, right? Music is shit, right? Like, there was nothing there, right? So, but I like this idea that we look forward, and there's a huge amount to explore. Right? There's a huge amount of stuff that we need to figure out how to do. And it's never been as exciting, I think, for a while for us to do this, right? So again, it's a great revolution. I'd be part of it, right? So one more thing, right? I'm looking for investment now. I don't know for the stuff I'm doing. So again, for you, for somebody put them in touch, right? I feel now I've cracked what I want to do. I didn't want to get investment 6 months ago because I was still figuring out, and I knew that whatever came on board would freak out with the U-turns that I was doing. I feel now I have a really good roadmap of where I'm going, especially with the newsfeed, especially with the Cyber Boardroom. So it's a good time to do that. And one more little thing I forgot to mention is that it's absolutely critical. I say any solutions that you have now, they have the constraint of cost. So everything I showed you here costs literally peanuts to run. The only cost is the LLMs, which you pass to the customers. So I think that's also very important, right? Everything you build now, if it doesn't cost anything to run, you have over-engineering. You have databases you don't need. You have systems that are up and you shouldn't need. Again, focus completely on that almost $0 or $0.1 marginal costs. And you find your architecture gets ridiculously scalable and powerful, right? And that's kind of where I am. So thank you.
Of our teams, just to get an idea how they implemented this, why this is useful, and how this is used in the world of AI. Just before I start and sort of introduce myself, a funny story. I've a software engineering background. My brother recently completed his degree. And what he said to me is that, do you know what? I've used ChatGPT recently, and my college has allowed me to generate all of my code. And I was kind of thinking, my goodness, if I had the power that ChatGPT has today. Anyway, from the introduction, so I'm a senior solutions architect at Veracode. Just to give you guys also a feel for the presentation, this is by no means marketing or a sales pitch. It's just my own sort of experience using the tool and also my experience using AI. I'm a former software engineer. I used to be a Java developer. Recently entered the cybersecurity world, mainly just out of excitement, as well as I've just been pissed off with all the security breaches that are happening in the world. And I just feel like, especially with the advent of AI, the space is evolving so quickly that we just cannot keep up. A little bit more about me. I'm actually a rock climber. Pretty much started my tech career at the same time as that. And a triathlete. So without further ado, this is what I'd like to cover today. So I've taken a couple of the slides from our company and sort of put my own twist on it, but I'm going to talk about the state of AI software security, as well as the issues and risks I see with generative AI. Probably this is the theme of the presentation. It's more of a cautionary tale. By no means I am an advocate. I love the tech. I think it's amazing, but I'm just going to put some call outs. Building an AI products in the application security space, so This is a solution that was developed by us with Veracode. It's called Veracode Fix. Sort of give you the journey, the early stages, the hiccups, how we went about doing it. I'll describe to you what a vulnerability is, just so you can see that kind of firsthand, kind of leading in with the AI product. Where I foresee the future of application security space, especially incorporating AI, and takeaways and some cautionary tales. So this is where, and this is taken from our company, but this is kind of where I see the state of AI software security space today. Obviously, we have the AI code generation and also increasing risk as this AI code is generated. Actually, only a couple of days ago, DORA came into play. I don't know if any of you are familiar with this, which is a regulatory and compliance focus. So we've seen a lot of that. Growing security debt massively, especially with AI code generation, some developer influence, and actually what we're starting to see across vendors with some of our customers is they're starting to say to us, hey, we're losing customers because we're not keeping up with this AI software security space. So it's a design factor massively at the moment. So I'm pulling off a couple of stats just to lead on to kind of current state. I mean, the first one kind of speaks volumes. We've got 70.8% of organizations that we currently see today. And by the way, all of this is referenced at the end of the presentation in terms of sources if you want to read into these. This one specifically is pulled off, we release the State of Software Security report annually. 70.8 of organizations have security debt. That's huge. And what's even worse, 45.9 of organizations have critical security debt in their code bases today. But where is the security debt? So is it in their first-party code? Is it in their third-party code? Well, yes, 90% of all security debt is within first-party code that I've written, code that I haven't taken from somewhere else. But 65% of the critical debt comes from third-party code in open-source libraries. So that's just code we're pulling in from somewhere else, effectively. Some of the scans, to give you a bit of insight, perhaps into the company, we offer an array of application security tools. We offer dynamic analysis, static analysis. The main difference between the two, dynamic is a black box. I'm pointing a crawler at an application, and it gives me the vulnerabilities and flaws. Static analysis is where I peek into the box. It's a white box approach. I look at the source code, and I'm getting findings out of these. And again, looking at these, I mean, look at these findings, 96 million, and this is last year, by the way, 96 million findings, 4 million raw dynamic findings. That's flaws and vulnerabilities within code, as well as 12.2 in software composition. So that's your third-party libraries. Last number slide, I promise. This is from various sources. Again, this is reference, but some interesting numbers here. I mean, 60% of orgs, and this is increasing every single day, have incorporated AI into their development tools, 48% in DevOps. This one I love. I mean, 80% bypass security policies to use AI, but only 10% scan most code. I promise I'm not one of those. 55% now in open source projects, 58.7% of AppSec teams struggling to keep up. By the way, can I just get hands from the audience? Is there anyone in application security in the audience? Any developers? Okay. Okay. Do you find any of these in terms of keeping up with application security issues within your? Are you seeing this across the board? Just a hand, yes or no? Yeah. So that's 2 slides. 55.1 organizations now consider using AI generated code, and 56 of devs encounter security issues in the code suggestions. So my kind friend Dinis already actually showed this slide, but I want to go perhaps just point out the top 5. So this is per the OWASP top 10. They're a foundation that releases application security findings across different areas within AppSec. One that Dinis actually mentioned is prompt injection. So these are kind of the main issues that we see across LLMs, so large language models. The biggest one, prompt injections. I mean, you can search ChatGPT memes and you'll find really funny ones of these, but it's just manipulating user inputs. Number 2, sensitive data enclosure, so that's user credentials, leaking API keys. Supply chain vulnerabilities. So this is like placing a backdoor within an LLM. Data model poisoning, so inserting harmful instructions in data. And improper output handling, so generating kind of harmful language, biased outputs, political statements, whatever it might be. But these are the kind of top 10 that we see across these LLM models. Okay, so I'm going to shift a little bit here. So I'm going to give you a tale of how Veracode went about building an AI product in the application security space, with all of that considered. So, what was the motivation behind this? We have static scanning products that scan code bases. We have some algorithms, by the way, if you want a good definition of algorithms, that's it right there. Coverage of lots of languages, frameworks, modeling of sources, things, propagators, and we scan trillions of lines of code. We give customers information, but now what? We tell them their code is broken. It's still up to you to fix it. We've got specialized knowledge how to fix a flaw, and maybe to some of us, I enjoy making security fixes, but to some devs, it's lots of fun work. And as a result, your friend technical debt, security debt is just pulling you. I get it. AppSec is a difficult problem to solve, especially now with the introduction of LLMs. And I mean, as a developer, I like working on the new feature. I like building the new products. And this guy kind of always sits behind the scenes and kind of catches you, right? That's the... So, solution. Well, automatically fix the flaws. We know the fixes. We can do sanitization for cross-site scripting, SQL injections, etc. It's mostly straightforward code modifications, but how? How do we do it? Let's use AI. Woohoo! Let's map some bad code to good code. Of course, using AI, there are some challenges. How do you represent the code? How do you train the AI to fix the code? Do we need to identify location, nature? Is it semantically correct? And how do we generalize for many different languages, CWEs? CWEs is just a way of classifying different vulnerabilities. So this is how we went about doing it. So sort of early in 2020, an incubator project was born. Our research team, some people much smarter than I am, looked at auto remediation, and the sort of whereabouts of this, we first looked at code rewriting techniques, but I think what they found is with this, it's too much manual work, having to configure configs for each CWE, and just easily thousands of rules to be written. Enter GPT. So we initially looked at GPT-2. This is prior to an acquisition, which I'll get to. Early days of the GPT or chat GPTs, but we realized this is open source. We can use it however we want. Later models, GPT-3 codecs, were only available through APIs. And we always knew that we need a very narrow application of GPT, meaning that we wanted to fix code, apply security fixes. However, we're not allowing manipulation, we're not allowing prompts. So, effectively, as opposed to a broad application of GPT that has a lot more focus. But 2022, we acquired a company called Juruna. The way the technology works, it references patches intelligently. I'm not going to get into the intelligently piece, but how to translate this into a customer code situation, rather than us just manually writing each and every edge case. This is kind of what it looks like. So this is a real AI-based solution. It's a closed source database, so it's proprietary data. It's supervised learning, so it's very much taught by our team of security researchers, developers. We scan the findings and we offer you fix suggestions, languages that we support, as well as how this operates. I've got a demo, actually, a quick demo to show you what this looks like in reality when this is running. But ultimately, it's just giving you code suggestions to fix security issues, is what it's doing. Okay, so looking at this from the offset, kind of the open source data sets and open source mode, we knew that this can be problematic by design. If you're looking at sort of licensing IP legal issues, as well as model poisoning, prompt injection, trained on open sources we don't have any idea of. So that's why we went about just curating the data set, making sure that it's trained on patches as well as generating code fixes that is taught by ourselves, so supervised learning as opposed to the semi-supervised or self-learning. What does an AI model look like to train? I won't get into the full technicals of this. You've got this simplified equation here. D is equal to A plus C minus B. So A is your vulnerable code, and the sort of endpoint is getting to fixed code, right? So in the middle, what we look at is, in the vulnerable code, what is that little piece? What is that vulnerable reference? And we will apply fixed reference. So it's trained on good code samples and creating reference patches to apply the resolutions. Okay, so some of you developers in the audience, I want to kind of show you what does a vulnerability actually look like. So I'll describe what the code is doing here. It's a Java code snippet. It's calling an array or creating a name within an array, and ultimately that prints it within a web page. Can anyone tell me what vulnerability this is? And why this is vulnerable? Yeah, go for it.
I mean, you're allocating spend, but you don't know what is the input, so you can allocate more, right?
Getting there. I would say look at this end piece, why that might be vulnerable. And if you can call out the vulnerability, even better. That's it. That's exactly it. It's a cross-site scripting because ultimately what's happening here is you're allowing an input on a web page that is not being sanitized. So this could be escape characters, it could be commas, quotes, whatever, depending on where I foresee it. But I was just curious what it would put out. And actually, it's pretty damn accurate, I have to say. So something that pops up time and time again is this shift-left approach. So sort of introducing application security and security practices from an early stage. Something that we advocate as well, but this is definitely a top one. So developer enablement, training developers, just making them more aware. I feel like with AI, it's kind of like a double-edged sword that, you know, it's attacker versus defender, that you've got this power, you can generate all this code, but at the same time, like all the stuff I pointed out, actually, you know, you could be really vulnerable. Cloud native security, so improving your microservices, containers, serverless architectures that Dinis nicely touched on earlier. AI, ML driven security, so leveraging AI and machine learning for a faster, more accurate vulnerability detection. That's, again, that sort of double-edged sword. Supply chain security. Are any of you familiar with the SolarWinds attack that happened a couple of years out? I mean, that's an example, right? It was an external piece of code that was running on the biggest businesses in the world, and you know, this is something that got compromised and caused huge damages to businesses. Zero trust, adopting zero trust architecture, identity verification, at least privilege access, making sure people that should have access, only people that should have access to things in software that they should do. Okay, so I've got a couple more slides. To be honest with you, I've only been in the AppSec space professionally as a career just under a year. I've been hacking away at computers, updating operating systems, coding away, but this sums up why I'm here. This sums up why I'm speaking today. The barrier for entry is much lower for generating cyber attacks, scams, impersonations. I mean, it genuinely terrifies me. My daughter is 4, and I don't post any images of her face, I don't put any video, simply because of this stuff. I know that it could be reused, weaponized, so I've kind of stood away from it. And I feel if there's one thing you can take away from this presentation today, don't get me wrong, GenAI is absolutely amazing technology, but we need to be the voice for guardrails. Simply because, hey, these aren't AI machine learning generated attacks, but these are real life attacks that have happened in the last number of years. I mean, a lot of you should be familiar with these. Yes, it may not be AI based specifically, but guess what? People can generate code, they can create attacks using AI to do these things. And the first one there, the power grid ones, that was not alone just taking down power grids. In Ukraine, it meant that people couldn't extract money from ATMs, which meant when you ran out of cash, you couldn't buy food. So, you know, and this is caused by software, effectively. Stuxnet, Carbonac, pacemakers. Hey, they managed to get into pacemakers too. That could kill people. Cars, remote control of vehicle functions, infotainment systems. These are really, really heavy things, and it's no longer just I've stolen your credit card details. It's real life things that could kill people. So the attacker versus defender analogy here. One last sort of closing thought. Have any of you, well, a lot of you, I'm sure, have used Hugging Face, but have any of you been following Hugging Face?
Yeah.
Most of you know what Hugging Face is?
Yes.
So, just for people that don't know, this is the biggest, I believe it's the biggest open source model space to download LLMs as well as utilize them. A couple of months ago, this was at 700,000. This just kind of shows you the acceleration of this. Funny, I actually looked at this today and I was like, oh, this is about a week ago I put this together, and there's DeepSeek already trending. So DeepSeek is this new Chinese revelation for an AI that's exploding right now. But do you know what? The first thought from a security head, I was like, wow, we've 1.3 million models, great, but what's the security of these? Who's training these? Where, what's the deal? So I did some research, and Forbes released an article on thousands of files containing hidden code, backdoor entries using these LLMs. Another guy at JFrog, a security researcher, same thing. He discovered about 100 different models that had the backdoors as well as just malicious intent for these models. So, phenomenal. And I'm not trying to, break Hugging Face. They've put in security practices in place to check the AI models, but it's just a cautionary tale. And sort of a closing point here. I've done some research on unrestricted GPTs. Yes, these exist. They are on the dark web. I have not tried them out. I believe there's a licensing model to these, but what these effectively mean is that I can go online and there's no guardrails, absolutely no guardrails. God knows what they can generate, but from an application security perspective, this now means that someone can just go in and say, hey, create a DDoS attack on this website, It mightn't be completely accurate, but it's going to lead you down the path. So I think these are pretty serious things that are happening. And that is it, I think. That's been my cautionary tale. I hope it hasn't been good.